All right. We'll start off with a little bit of interpretation. You guys did okay with graphing these, but after yesterday, can you tell me what it means? Okay. Can you tell me what it means? Well, in the year 2021, you probably only play lawn darts if you're a redneck.
They changed like the shape. I don't know because my dad has some. My dad has some. Like darts like that. Yeah.
Lawn darts are exactly what it sounds like. The darts, the metal tipped darts that you throw at a board, except about that big. And you're supposed to arc them to hit an area in front of you, but people are stupid and they throw them straight up in the air, and then it's a game of chicken to see who can last longer before they run. And there was a point in time where different government regulations were coming out banning them from store shelves because people would stay too long and take a giant spike to the head. Particularly since they were marketed as a children's toy. Yeah. But do the thing. And tell you, you're going to need a calculator, graphing calculator for it. Let me guess. We answered the first one just fine. We're struggling on the second one. Okay. This one isn't going to count as a daily quiz. Okay. Because the second one we haven't explicitly talked about yet. I wanted to see what you could do. I wanted to see who could take it the next step. Who could figure it out. Did anyone figure it out? Maybe? What do you think? You did it all the way back in Algebra 1, but that was a long time ago. Okay, context of the problem. What is t? Time. What is h of t? Height. So when I ask how high does the dart go, what am I asking for as a feature? Vertex, right? So the vertex, I could go old school, negative b over 2a, right? Negative b over 2a. All right.
Wouldn't it be times 2?
Oh, I didn't. I hit 2. It just didn't do 2. But then I'm slightly cross-eyed right now, so I might have just missed the 2 entirely. I haven't done a 3-hour, 3 hours of sleep and come to school and try to math in about a year and a half. So here we go. I went to bed around 1. Baby bear started squawking around 4. So, if I plug that in, negative 16. Now remember, I can just use the answer button, so I don't have to type that again. Squared. That is not a squared. Squared. There we go. Plus 35 by my answer. Plus 4. Yeesh. Now that might be the correct answer for the height. But maybe I want that as a decimal so it's a little more understandable. 23 seconds. Billy Bob's got an arm. It was in the air for 23 seconds. I want you to think about that. I just made up numbers, by the way. So. Oh, wait. Yeah. There's the time. Okay. I'm going to screw up a lot today. I'm tired. Okay. There you go. 1 point something. 23 feet in the air. Actually, that's not. That's more like. Yeah.
That's not a big arm.
You don't got much time to get out from underneath that.
23 seconds. That's wicked.
23. Isn't like professional punt hang time like 7 seconds? Yeah, that would be insane. But we know how to find the vertex. We were doing this yesterday. If the height is 23 feet, let's take this over here. Everyone go to Y1. We're kind of jumping ahead. This is a different section, but I think it fits well with what we just did. And type in your function, negative 16x squared plus 35x plus 4. Now, we just found manually that the vertex was 1 point something, 23-ish. So I'm going to make my window reasonable domain and range. Does it make sense to measure the height of the lawn dart before he throws it? So I'll start at 0, and I'll go out.
30, 25.
Where? How much time was it until the vertex? 35, 30 seconds, so like 1 point something. I'm betting it's not going to go 10 seconds, right? Maybe I'll go like 2 or 3. Like, it isn't going to be very far. Okay. It doesn't make sense for the height to go negative. I'm going to leave it -1 just so I can see where the y-axis is. Or x-axis, sorry. And we said that the max height on it was 23 something, so maybe I'll say 25. Actually, I'll back this up to -1 as well so I can see the axes. Okay, I'm just trying to get a window that's going to show me this graph. Now we asked, when does it hit the ground? When does it land? What is that on this graph? Okay, you're saying the number. I'm asking what is the feature? X-intercept. There we go. The x-intercept. And this is where we're kind of jumping ahead. We know that we can find this maximum, right? We do second calculate to find the maximum. Which of these will find me the x-intercept? The zeros. Do you remember that from Algebra 1? That x-intercepts are also called zeros, are also called solutions. Okay, so I could find when that's going to land and say it's somewhere between 2 and 3. And say after about 2.3 seconds. Okay? So, I just wanted to see if you could take it to the next step. But, y'all, when you're trying to find stuff on a graph, second calculate. That finds stuff on graph. Okay? So I just wanted to see if anyone could remember it or maybe take it to the next step from what we did yesterday. This is not a daily quiz that's going in a grade book. Just like, I don't know, not cross it out, but just like put a check mark next to it like, yay, we did a thing. Okay? I just wanted to see what you could do. Okay, the homework, someone pointed out at like 11:30 last night. Isn't this the same thing we did last week? Yeah. I said it's been rough lately, and I did not even notice that I did not change the numbers. You did the same assignment twice if you did not catch that. No. No, I'm not going to check it twice. No. If you did it a second time, was it easier?
Yes.
So, no. Those are dirty words in my room. We don't do that here. Okay. All right. But wait, I do gotta talk about that. I told you, you're doing okay. Okay, just from the engagement in class, I could tell the majority of you were doing okay. I didn't think you were doing that good, so you kind of shocked and awed right there. I said at the beginning of class, I have not had an Algebra 2 class do that in about 5 years, maybe 6. The last time I had a class do that was the group that had the Council of Ladies, and they had 3 trays of brownies off of me by the end of the semester. So maybe we need to get a little more vocal and a little less, dude, and instead focus up here and wreck me and get some brownie points, okay? Because y'all are doing good, okay? Now, like I said, for any of you who were listening, my inclusion algebra class, I've got 7 boys in there who are just refusing to even pick up a pencil. We got 3 teachers in there.
What number does that go to? The F?
9. So I've got kids in there who are just refusing to do anything. A teacher literally sitting next to them and saying, "I will help you do every single bit of this." They also don't have homework. I don't give homework in that class. We do every scrap of it in the room.
So how do they have that many missing?
Because they're not even attempting it. They're refusing. Okay? They are literally refusing to even pick up the pencil. So that's where that is. Over here, freshmen. Freshmen naturally come up to the high school, especially in algebra half. That's our lowest math. These are the kids who could not go straight into algebra 1. These are the kids who probably didn't do what they should have in middle school, and because of the way middle school works, they just kept getting passed up the ladder. And now we have a third of all coursework for the entire class was not even attempted. So now they're going to find out. Those parents are going to come in tomorrow, and I'm going to tell them how our class runs. Open notes, open book, the solutions are online. You get me before school, after school, Spartan time, lunch, my prep. You have Remind where you get a tutor in a pocket. You have all of this stuff. And they decided not to do a third of the work. And then they're going to go home and they're going to commit murder. So that just happens with freshman classes. Freshmen, on average, the first semester for freshmen, I think it's something like 1 out of every 5 or 1 out of every 4 freshmen fails a class, just because they don't got it through their head yet that they have to do it. So, but then you look at kids who have been in high school for a while. They actually did their work. Huh. God, it's almost like doing your work in my class necessitates grade. Like, all you got to do is show up and do the thing. And if you do the thing and you're still not getting it, ask a question. That's it. Okay? That's all you got to do. So, that's where we're at. Y'all are killing it. Like, really. I actually got the dirty look and the grumble from my desk is in the corner of our bedroom. So it's like 12:30 at night. I'm entering the grades and I'm like happy flapping and like bouncing in my chair, and my wife got mad at me. Like, seriously, you all just, it gives me the warm fuzzies. That was great. So, let's finish off 4-3. Does everyone have their graphing calculator?
Yes.
Okay. Yesterday, I showed you that you can take any 3 coordinates and make a quadratic out of it by a 3-variable system. Okay? You do not have to write this, but the idea this is the general form or standard form of a parabola. So if I got a whole bunch of x's and y's, I can turn that into a thing squared plus b thing plus c is y. And I can do 1, 2, 3 of them, simplify them, and they'll turn into a 3-variable system. Remember when I showed you the little trick that the calculator will do a 3-variable system for you? That's what the regression is. Those regression features in our calculator, they are solving a system in the back of the calculator. So, instead of us doing it the long way, let's get that button instead. Okay, let's get that button instead. So, quadratic regression. Here's a table of values. We need to put the table of values in our calculator. Do you remember how?
Yes.
Stat, edit. Before I go putting things in, let's stop and look at the table. I'm going to have to change something. What about the time?
That was 2 hours.
Most number lines don't go 8, 10, 12, 2, 4, 6.
No, it's military.
24-hour time format. Okay? I got really used to, like, my wife gets mad at because I set all of my clocks, my watch, everything on my phone. It's all in 24-hour time format. I got used to that because I worked night shift in my undergrad. So you know what happens when you wake up at like 3 in the afternoon to have breakfast, to do some homework, to go to your night class that starts at 7:30 p.m., do a little bit of work, go to work at midnight, get off of work at 8 in the morning to go to your 9 o'clock class, go pass out around noon, wake up at 6, go to your next night class. Like, I got used to 24-hour time format because when you have a class that starts at 8, but you also work at 8, a.m. and p.m. starts getting weird. So it's really easy. If it's afternoon, add 12. That's it. People get wigged out when I say, like my schedules, like the schedules that I print and I put next to the walls, I have them in 24-hour time format, and someone will look at it and say, "What's 15:15?" Like, yo, 15's bigger than 12, right? Yeah, subtract 12. Like, it's not that hard. It's just 15 minus 12. Oh, 315. So when I put this in, I'm not saying 2. What am I saying? 14.
1400.
What am I saying? What am I saying? 18. Okay. Now go put your data in. And now that we got rid of Frank's X, look at how much faster this is.
Oh my lord.
And he was in a toxic relationship. Done. So now do you believe me? All of the fighting that we did with this thing before, it really wasn't my fault, I swear. Yeah. Okay. So I got a bunch of data. Right at the top of the page, it says quadratic regression. Do we remember where linear regression was?
Oh no.
Ooh.
Stat calculate.
Stat calculate, because I'm calculating things from my table. And now, instead of linear regression, right below that is quadratic regression. I want you to look even below that, and below that, and below that, and below that, and below that. We're going to do all kinds of regression in here. I said you're going to be good with the calculators after you leave this class. Okay, so everyone got quadratic regression? Well, the same thing that you did for linear, it should just have, Zoe, you know these things better than me. Isn't one of the regression, it just says x squared to do the quadratic regression? Oh. I thought you like hit the regression button and then one of the options is x and then x squared and then x cubed. So I think if you just hit regression x squared, it'll make the quadratic regression. I think. Okay. Now, remember on TI-84, it's going to have this cute little pop-up menu that asks me for what lists I want to use and where I want to store it. If you don't have that, if you're doing old 83, you would just comma list 1, comma list 2, comma y1. If you're on an older calculator. But I think everyone here is either rocking an 84 or the Casio. Or no, Jaden's got the 83, but you're cool with this? Okay. Just making sure. Oh, y'all know, if you don't have a calculator on hand to do, I don't know, your assignment, where is it on your laptop?
Search bar.
Search bar. Okay. You go down to TI-83 plus flash debugger. Someone remind me if I don't send it out on remind, someone remind me. I have that old 10-minute video that goes through linear regression. So it's just the same thing but quadratic. Okay. All right. So I want to store this. How do I store it again? The function y1, or if I'm on an 84, I get that cute little shortcut. Alpha trace brings those up. Okay. Doop boop boop. So I did the thing, and now it tells me y is approximately negative 0.469x squared plus 14.716x minus 36.121. Okay. 3 places. I don't care what the directions say. We go 3 places. Now, at the bottom there, I actually have on here because I had to do a purchase order to get the 84 emulators for the math teachers. I used to have the free emulator of the TI-36, which is why that's on the bottom there. If you have a 36X Pro, and I think there's like 2 of you that have that, it'll do all this regression stuff. Okay. And the nice part about it is on the left-hand side, what is it, like 4 buttons up? You see one that's just got alphabet soup on it. It's like X, Y, Z, T, H, A, B, C, D. It stores all of this stuff in there. So if you need to retype it, you just cycle through that button to say A, X squared, B, X, plus C. So it'll still store all of it for you without being able to graph. But I got a model for the data. Use your model to predict the high temperature for the day. That's the important part. Use your model. Don't just go to the table and say, about 81. Like, that's the raw data. I want the model. The model is going to tell me I can expect this. The high temperature. What are they asking for? The peak, the vertex, the maximum. So when I stored this, it shoved it right there. So if I now graph it, well, if I go to a normal graph, it's not going to show me too much, right? So now we're going to go to the window. Change the window. The context of the problem, what is X? Time, specifically hours and temperature. What is a reasonable time for me to go out to? 24 hours, the whole day, right? Oh, so 0, which is midnight, to 24, which is midnight. Okay, temperature. Maybe I just look at my table and I say, well, this is Sacramento, California. They would probably crap themselves if it got down to negative 10. In fact, if it got to negative 10 in California, you would have structural disaster because their buildings, their plumbing and everything isn't winterized. Y'all remember last winter when like Texas just like people were trying to make terracotta furnaces out of flower pots and candles? because their whole grid just failed. Okay, so -10 doesn't make sense. What does make sense for temperature on here? Okay, not even 0, right? We're talking about Sacramento, California. 50, 40? I don't know. I'll try 50. That's what I heard.
Max is like 120.
I mean, if they get a real ugly heat wave, yeah, they're over 100. Yeah. I'm just gonna say 100 because my table only went to 80 something. Can I see it? I can see it. There it is. So, second, calculate my maximum. It appears to be somewhere between there and there. As long as it's in between there, I don't care. Press the button and get. Oh, when it asks you for a guess, just hit enter again. That's it. That's so you can guess and check. Error, no sign change, meaning you didn't move Blinky. Like, you did maximum. You just hit it twice. You actually need to put Blinky on the left. And you can also just type. Make sure the arrows point in at each other. Skadoosh. Okay? So, use this correctly. What is the high temperature for the day that I can expect?
79.
About 79 point... Is that an 8? Or is that 3? Okay. 379 degrees. And we'll make sure to put degrees Fahrenheit on there.
That's Celsius.
79 Celsius, you're dead.
Yeah.
Water boils at 100. It's like my couple of my gaming buddies. They're in Ontario, and they'll say something like, it's 38 degrees out today. I swear I'm gonna die. Around here, you'd say 38 degrees. That's shorts weather. Until you do the conversion. I forget if it's parentheses or not. It's 9/5 Fahrenheit minus 32 or plus 32. Oh, but it turns out that's like over 100 degrees. Okay, it's bad. It asks, at what time of day does that occur? How did you get 42? That says 0.697. Take the decimal train times 60 minutes, right? So 697,145. 0.697145 times 60 minutes. So it's 1541 and change. So I would say at about 3:42 in the afternoon. Okay. Unit analysis. Y'all remember physical science? If I have 15 hours plus 0.697145 of an hour, I take that times, there are 60 minutes to 1 hour. Remember this? Remember cross-canceling? The decimal train was from the vertex. It was 15 point blah, 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 blah. So it's that many hours. So if it's point this many hours, take that many times 60 minutes. Okay? And you can keep going if you want to be really pedantic about it and you want to keep going to minutes and seconds and microseconds. Like, you can keep going if you want. So, blah, 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 blah. I know how to do regression. We did it before, now it's just a new button. Go. Same thing, but now we're talking Denver. You do a problem now. Same thing, different numbers. Same as our linear regression. We're just going to hit quadratic instead. Like this. Holy smokes. Our Spartan time list is 61 pages long.
Oh, I think it
If freshmen have all A's and B's for every grade reporting period all year long, they get out fourth quarter. I would say at that point, those kids have shown that they're doing what they're supposed to. And of those 61 pages, the first 27 are just freshmen. God, freshmen. All right. All right. No, not you. You. Okay, if I start completely from scratch, we go stat, edit. We start typing 6, 9, 12, 12, 15, 18, and 9 p.m. is 21. Okay, with 63, 76, 86, 89, 85, 76. That's supposed to be an 85. It's an 86. Okay. So once you got your data in, All right, let's see who remembers this from before. I got my data in. I'm about to do my regression. Do you remember how to turn the correlation coefficient on? That tells you how good of a fit it is. Hey, it's almost like we wrote it down in our notes, or you should have. How do I turn the correlation coefficient on so I know how good of a fit my model is? They didn't ask for it, but I want to know, do we remember how to do this? If you're on an 84, you luck out and you get to just go to mode and turn your stat diagnostics on. That's it. If you're not on an 84, you have to go second. Right above 0 is catalog. You catalog your way all the way down to the D's. And you have to turn diagnostics on. Okay? So if you have to do that, if it asks you for it, you can't say that we didn't go through it. Stat, calculate, quadratic regression. Make sure it's the right lists and store it. Okay, now before, I was manually changing my window. Do you remember how to get it to the perfect window? Zoom 9. Zoom to my statistics. See, the problem is, it's not going to zoom to any statistics. Okay. Zoom to fit. Why didn't it zoom in on my data? Because my stat plot is not on. If I say zoom to my statistics, but I don't have my statistics plotted, it won't do it. So I can turn plot 1 on, and now if I zoom to those same stats, it'll go right where I need it to. Okay? Now you could just manually change your window. You don't have to do that. Look at your table. Do 24 hours again? Go from like, what, 50 to 100 or something? Okay. I just want to show you options because it works, like, different things make different sense for different people. All right? It's not often that I'm going to force you to do things a certain way. All right. So there's my equation. Y'all write it down? I could scroll through it, but I don't want to. No, 3 places. Okay. So once I have it, they ask me, what's the high temperature? At what time does it occur? So they're asking for that maximum again. Calculate my maximum somewhere between there and 22. As long as it's pointing in at the maximum, that's all I care about. So 2 something. So 873, 492. 0.873, 492. 2:52 in the afternoon.
Wait, why'd you So it's 12.8
How you get that?
something, right?
Did you get the graph?
So it's minus 12.
Second, calculate
If it's over 12,
And it's
maximum.
Okay, maximum.
you get 2.
Because we're looking for the maximum, not
And then
the
you take
bottoms.
decimal times
So now
60.
move Blinky over
Because
to
right
the
now
left.
it's in terms of hours.
Okay.
So if you do times 60.
Move Blinky over to the right.
This is what I did.
Yeah, I got what he got.
80. Would you get 88?
Enter.
Enter.
88.4.
Well, yeah, that's the high temperature. This is the time it occurred.
It's 2 hours and 52 minutes.
X is the time it occurred. Y is the temperature.
How did you get? I mean, Harrison, you're not. That's not. That doesn't have anything to do. That's
No, no. I took this decimal train here because this 1400 is 2 o'clock.
Okay.
It's that many hours. So if I take this decimal train times 60, I find out how many minutes. Hours, minutes. That's what this is.
252.
252. Yep.
Okay. So how do you get that other number? You just take it.
I took the decimal train back to the main screen.
So you basically photo head and then put it back in.
Yeah.
And then times 60.
Yeah.
Oh, sweet.
That many minutes. That decimal train, it's that many hours.
You don't have to do that.
Well,
I mean,
What
what time does it? At what time does it?
well, because it's saying it's 0.87 of an hour. Do you say that right now it's 10.83?
No.
No, it's 1049. So
how do you get minutes?
you take that decimal train
0.87
times 60
that's
minutes because it's hours, minutes.
And then you can leave that one too.
Yeah.
Okay, cool.
That's
Would
it.
this work just like 252 is kind of.
I would say at 252, you're approximately this many degrees Fahrenheit.
Yeah. So you
Yep.
just do 14. Just mark it down. 14
Yeah, labels are good.
All by myself.
So can you just
Air knuckles.
I am very excited about my job.
52 seconds?
No, 14 hours, 52 minutes. Hours, minutes. Y'all good over here? Okay. Is Casio working out okay for you? Or whatever app you're using?
It's different. But it doesn't work. Like, it
Well, I can't help you with that.
because I'm forced to type manually to find the maximum.
Oh.
I have to type manually the A, the B, and the C function. You've run out of tape, by the way.
Yeah, I can't help you with that. Like, here you go, bud. Oh. Okay. Show me some thumbs because we got to know how to do this when we. Hey! Come on now. Show me thumbs. Because if we can't do it with quadratics, in chapter 5, we're going to put a line, a parabola, a cubic, and a quartic all on the same graph. We're going to put them all on the same graph, so we have to know how to do this. Okay, one more. Let's try 7 up here. Start by getting the data and the model, then we'll talk about the analysis. Okay, if you're switching to that, you mind if I use this just to see if I can figure out where you're. Okay. Yeah, you do your thing. I'm gonna see if I can make this work. Okay. Exit. Okay. Exit. Regression.
So, do you want to do that? The time's already done. So, if you want to. So, staff, edit. So, staff, edit. Now we put it in the
Yes.
Yeah, it doesn't make sense because dimension error usually means you have something missing in one of the lists. What the hell? Okay.
Now we're gonna find the regression. So stat.
I was like looking for
Calculate. And then find your variable. So down here is your variable. So variables. And then go over to y variables. And push enter. Just enter. See what comes up. You just want to then enter. For calculate. And then you get that equation, right? Yeah. Okay. So now if you graph it, we might have to change that one.
There's the right A that
No, teaching times. So I need to change that window because I can't even see it. So window, and then change.
Wait, do I hit? The minimum.
Yeah.
0.05.
Good job, I chance. Y equals negative. Oh,
About
never mind.
4 seconds. Well, no one's gonna be shorter than 2 feet, so.
True.
I think I'm gonna make it 3 feet, maybe 3 feet 6. Sorry. Let's just do 7 feet, so might be something really fast.
What do you do for the minimum?
Oh wait, it's not the height of people, it's the height of the wall. Okay, so anyways, wow.
Second graph.
This one's just really fast.
Oh, 4 seconds. 1.5.
Represent maximum. You remember maximum.
Well, I figured this.
What is the ball's maximum height?
Well, I wanted to see that.
Oh yeah.
Y.
So, second calculate maximum. And then I just type in -10, you know that's gonna be on the left.
I can just do it. No.
No,
I'm still learning how to use this calculator.
we're showing him everything.
Guys, we need more
I just did the thing where you do
Sorry about that pencil.
I like this pencil. It's very special.
I got a shot in the back of the head for it. So. I need 4 more.
Okay, scroll over to left side.
It's a baby's oh. We need 9 more.
This is right here, right?
Yeah.
I even got those labeled as dimension 1 and 2, and it's still not doing it. I don't.
Yeah, that's. I'll just figure out how to
No,
do this.
like, but Casios are better. They're actually better than TIs.
Cap.
It's just I don't know why it's not doing that because it's been 12 years since I've done it.
Yeah.
Casios are better.
I usually figured everything else out, but I don't know how to do this, so I'm just gonna try to.
Okay. All right. Second plus 7, enter 2. I started all over. Oh no. I got data in the table. How do I put data into the table? Stat, edit, start typing. 0, 1, 2, 3. That was easy enough because it's just time and seconds. Don't have to monkey with it. Height and feet. 5, 5, 6, 5, 5, 4. I'm going to want a model out of this. It specifically asks for a quadratic model. How do I get a quadratic model from my data? Stat. Calculate stuff from my table. Use quadratic regression. Alpha trace. Uh-oh, I'm on an old TI-83. How do I store it? variables, the y's, the function. Okay. And goes and finds me some stuff. 1/2 x squared plus x plus 5.5. Okay. Find the quadratic. Check. Use the model to estimate the height of the ball at 4 seconds. Now I can literally just use a times 4 squared plus 1 times 4 plus 5.5. Like I can just manually type that. I just stored it. It's right here, which means it's going to auto-populate a table for me. 4. There it is. Additionally, I could go to my graph itself, and I can trace my graph out to 4 seconds. I could do it like that. So I can do it manually, I can do it with the table, I can do it with the graph. Trace. Okay, what is the ball's maximum height? Second, calculate stuff on my graph. I'm going to find a maximum. It appears to be somewhere between -9 and 9. Right?
Yeah.
And it's still pointing in. What do I write? The maximum height. When does it occur?
1 second.
Exactly 1 second. I said, when you put Blinky here and here, it takes those numbers and it puts them into an algorithm. When we did our 3 variable systems, do you remember if you like accidentally said 12 minus 7 is 6? You were close by the end, but you had these nasty fractions, right? It's taking the Blinky numbers that you just picked and putting them into an algorithm. And sometimes it's going to have tiny round-off error. Just like sometimes you were really, really close. Okay? So, do you remember how? We're just going to keep going, right? Your assignment is only 4-3. But show me you remember how to FOIL. First outer, inner, last. First outer, inner, last. Come on, you know how to distribute. Yeah, you do. Okay. First, you take the first thing times the first thing. O, outside. You take the outside thing times the outside thing. I, inside. The inside thing times the inside thing. L, the last thing times the last thing. But then, combine like terms, right? And get x squared plus 6x plus 8. Okay, now you say, I forgot this. I don't know how to do this. I would like everyone to not touch your calculators You are not allowed to touch your calculators. We are going to go all the way back to 3rd grade.
Oh gosh, multiplication. Oh gosh. I don't know if I remember.
Go!
I know.
Don't touch your calculator. Let's roll all the way back to 3rd grade. Can you do multi-digit multiplication?
I'm pulling that 0. Placeholder 0. Good.
All right. Ready to get your mind wrecked? 2 times 4 is 8. 2 times 1 is 2. What did you do next? A 0 is a placeholder. And then 1 times 4 is 4. 1 times 1 is 1. Now what? And you said 168. Okay? Now specifically, I'm going to ask you other questions about this. If you could, please tell me, what place value is this? What place value is this? What place value is this? 100 is 10 to what power? 10 is 10 to what power? 1 is 10 to what power? Say, where are you going with this? Two times 4 is 8. 2 times x is 2x. X times 4 is 4x. X times x is x squared. And because you put everything in its proper place value, you just grouped like terms into 168. 168. You've been distributing polynomials since you were in 3rd grade. You just didn't know it. This legit works for big, ugly polynomials. If you have no idea what you're doing, I could take x to the 3rd plus 6x squared minus 2x plus 5 times 3x minus 1. Instead of distributing all of that and writing it out longhand, I can treat those like digits and say 1 times all this stuff. Bleh. Move over, 3x times all this stuff. And because you moved over, why am I talking over you again? This is a way to multiply. Not everyone likes this way. Some of us would rather just go to Arrowtown and do the spaghetti monster with something this big. Someone in here is going to rather do this every time. Someone else is going to want to write it out like this. Someone else is going to Punnett square. Remember dominant recessive traits? X times x is x squared. X times 4 is 4x. X times 2 is 2x. X times 8, or sorry, 2 times 4 is 8. And then, if you put these in descending order, your diagonals are always going to be like terms. All I wanted to show you is there's different ways to multiply things. Okay? Now you notice, every time we did this, regardless how we did it, we took these two and added them together, right? So factoring a quadratic is doing FOIL in reverse. Because you know that you're going to have to add together these two terms in the middle. 2 plus 4 is 6, but isn't 2 times 4 also 8? That's how we factor them. If I see this quadratic, I'm looking for what times what makes C but adds together to make B. Okay? In ax squared plus bx plus c. Now this only works if a is 1. That's why, the top of the title, it says, factoring expressions, the first one that we're going to have is factoring where a equals 1. When a does not equal 1, it starts getting weird. Okay? So, now we find out who knows their multiplication facts. What times what makes 20 but adds up to make 9? Hmm? You can, but that's like saying there's a fly on Dawson's shoulder. I'm going to just come up and just wreck them. Okay, it's kind of overkill to go to System Town when it's just, hey, do I know my multiplication facts? Now, sometimes you can't think of them off the top of your head, so you got to go old school and write out, well, I have no idea what times what makes 20. I know 1 by 20 does. I know 2 by 10 does. 3 doesn't. 4 does. And you know when I hit 5, I get 4 again, and it's the same thing? If I'm going in descending or in ascending order like this, and I start repeating myself, that means I've hit all of them. Right? Because now I'm going to go to 5, and then it's going to go not 6, not 7, not 8, not 9, 10. So if I start repeating myself, then I know that I've exhausted my factors. So we've got all of these as options. Which of them make this true? 4 and 5. So I will break up my quadratic into a positive 4 and a positive 5. What's the only way that I make x squared? X times x. And if I want to know that I'm correct, you can just FOIL it out and make sure that it does equal that. Yes?
What if you had 5?
What's 5 times 4? What's 4 times 5? What's 5 plus 4? 4 plus 5. Because addition and multiplication are both commutative, the order will not matter. That's a valid question, though. Okay, 72. I don't know about you, but not too many folks know 1 and 72, 2 and 36, 3 and 24, 4 and 18, yeah. 5, no, 6 and 12, 7, no, 8 and 9. None of those make negative 72. 172, 236, 324, 418, 6, 12, and 8, 9 with negative, 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 negative. Do I want to do this? Now, will it get me unstuck if I have no freaking clue? Yes. Okay. If I'm moving snow around the neighborhood and I just slide a little bit off the road and I get hung up on a drift, do I want to get out and shovel?
No.
Will I do it so I'm not stuck anymore?
Yeah.
Yeah. So if you don't know, list them. Okay? It's either that or you got to keep guessing and checking on a calculator. So out of all of these, the magic pair that adds up to a important positive 14, x minus 4, x plus 18. Okay. If you ever see a negative out front, it's going to mess with things. Because now, how do you make a negative x squared? It can't be x times x anymore, because it's a negative x squared. How do I make a negative x squared?
Put a negative sign or subtract.
What times what makes negative x squared? Negative x, positive x, right? And that's going to mess up your FOIL, because now some of them are going to be positive, some are going to be negative. So instead of dealing with that whole mess, you'll just factor that negative out. Like this. Factor the negative out. Now, what factors of 12 add up to a negative 13? Negative 1, negative 12. Now this part is going to be x minus 1, x minus 12. But don't forget that negative. So this is one way to write it. Technically, you could have had negative x plus 1 times x minus 12. Technically, you could have had x minus 1 times negative x plus 12. All three of these are correct. But do you see how in the purple, having a negative on one of the x's just kind of makes it go cross-eyed? That's why I say, like I did in the blue, just factor the negative out so you don't have to deal with it. Okay? It's like, you're out and about with your special someone, but you also have to watch your kid brother. You go shove them in the corner and say, just go over here. Play on your leapfrog. I don't care. We're going to do our thing. Just don't forget your kid brother at Burger King. Okay? It's happened. So, I did some, you do some. All of the above, A, B, and C. Because they've all got a little bit different flavor to them.
Yeah. So would I distribute the negative into both of them?
No.
Do...
You just leave it there.
Okay, so this is correct?
Yes.
Okay.
Or you distribute it into one or the other. For the same reason that you wouldn't, if I had 3 times 4 times 5, I wouldn't say that's now 12 times 15. You don't just, because these are multiply, not add.
Okay.
What's the thing? Oh, that thing. Gotcha. Yeah. Okay. Now remember when I say I want open notes? I want you to be supported in here. How many of you remember multiplication charts? Okay. I legit have told kids in Algebra 2, if you can't figure that out off the top of your head, there is nothing wrong with going and finding yourself an old multiplication chart. Like, here we do, Google Drive, my Drive, old math stuff, slides and templates. There you are. Those. Okay. 20 by 20. So if I'm looking at, go away. If I'm looking at factors of 40 and I don't know them off the top of my head, there is nothing wrong with coming in here and highlighting all of my 40s. I see a 40 there. I see a 40 there. A 40 there. 40 there. There. And there. And they're always going to occur in this arc. Okay? So each one of these is going to give me a factor pair. This tells me 4 by 10. This tells me 8 by 5. This tells me 2 by 20. So you use these way back in the day. What factors of 40 add up to 14? Come on now. What factors of 40 add up to 14? What factors of, careful, positive 30 add up to negative 11? Before I do this one, I'm going to take that out. Okay? Take that negative out. Now, factors of negative 32 that add up to negative 14. Okay? Wait, negative 16 and negative 2?
No, positive 2.
Okay.
Yeah.
Is there a negative one?
Is there another one? Negative on the.
Now, either you can move that negative in here, or you can just leave it out front. All three are correct options. Okay? I'm going to just caution you now because of what we're going to get into with not just quadratics, but cubics, quartics, quintics. Get in the habit of taking that negative out. If you can have x minus a number, it's going to be very, very beneficial for us later on. Okay? Yeah, that's about there. So, your assignment is only 4-3. There's not a lot of it. If I remember right, I only got like, 5 problems? Because it's the calculator stuff. Okay?
Only do it once.
Yeah.
So the big X is the